Classification of matter, Chapter 2. Matter has inertia, mass, and volume. Mass, you should know what mass is. You should know what volume is, how much space something takes up. Mass is how much particles are in an object. Inertia is the ability to resist change or movement. We're going to talk more about inertia later on. Matter is classified according to its physical state, whether it's a solid, a liquid, gas, or plasma. Matter may also be classified by its composition. It may be homogeneous or heterogeneous. So there's homogeneous materials, there's heterogeneous materials, there's substances or mixtures, homogeneous mixtures, heterogeneous mixtures, and then there's elements versus compounds. And there's a nice little diagram on my website that kind of breaks all of these down in a nice organized fashion. A mixture is matter that contains two or more different materials. Sometimes you may need the microscope to actually see the mixture. Okay, in the textbook, you should have already read 2.1 and 2.4, and those are about physical changes, physical properties, and one of them is about chemical change and chemical properties. Physical change, some examples are like pulling, cutting, grinding, melting, dissolving, boiling, dissolving and boiling. It's like just change. Some of those are just changes of state, going from a solid to a liquid, liquid to gas, etc. Those are just physical changes. And ice melts, that's just a solid to a liquid. That is not a chemical change, that's just physical. You started with water, you still have water in the end. Distillation and filtering are other examples of physical changes. You can distill something to get the particles apart. You can filter them. You can filter the sand from water. Okay, just physical change. Again, more about changes of state. There's melting point. That's where it can go from a solid to a liquid. A boiling point, liquid to a gas. Sublimation, going straight from a solid into a gas. Think of dry ice there with sublimation. That is not a chemical change. Those are physical changes. What you start with is still what you end with. It's just in a different state. We talked about the dissolving being a physical property. So there's something called specific solubility. It's the amount of solute that will dissolve in water at a certain temperature. So if you have 2 grams of salt, will dissolve in 5 milliliters of water only if it's at 20 degrees Celsius. If you have a colder temperature, maybe not all the salt will dissolve. So if you have 2 grams of salt, you have 5 mils of water, it needs to be at 20 degrees Celsius for all of that to dissolve. So dissolving, a physical change. Fractional crystallization is just meaning turning into crystals. It's the process of separating out different solutes in the same solvent. So let's say we took some salt, sodium chloride, and some potassium bromide, and we dissolved it in water. And if we let the water evaporate over time, salt will crystallize first, and then eventually the potassium bromide. So the less soluble solute forms first, and usually when they form, they are in crystal form. But still, that is just a physical change. The water is just evaporating, and we started with salt, we still have salt. We start with potassium bromide, we still have potassium bromide in the end. Physical properties, length, mass, volume, and again, those are known as extensive physical properties because the amount is important. It depends on the amount present. For example, if you're measuring mass and you have more of it, the mass is going to increase. If you have less of it, the mass is going to decrease. Same way with length and volume. So extensive depends on the amount present. If it's an intensive property, the amount present does not matter. For example, color. If you have 5 grams of copper or 500 grams of copper, copper is still going to look the color. It's going to have that gold color to it. Melting point, boiling point. It doesn't matter if you have 100 grams of ice or 5 grams of ice. Okay? The melting point is the same. The boiling point is the same, 100 degrees Celsius. So intensive, it does not matter how much you have, those properties are consistent. Extensive properties are properties that depends on how much you have. Okay. Chemical change and chemical properties. Burning, we're changing, the starting and end are different. Digestion, corrosion, rust, those are all chemical properties. Chemical changes take place. For most of these, you're going to have a change in temperature. The rule of thumb, if a precipitate, gas, color change, or energy change has occurred, a chemical change has taken place. And I'm going to do a demonstration in class to show you what a precipitate is. Chemical properties, again, reactivity, flammability, stability. Remember, what you start with is not what you end with. You have different items from the beginning until the end. And then again, there's usually some type of temperature change that took place if you have a chemical reaction. So chemical changes take place because of chemical reactions. Okay, and that's where we're going to stop with the first video.